Have you ever looked at the sky and noticed a plane flying overhead with a fluffy white cloud thing trailing behind it? Well, that thing and others like it are called contrails, and they're actually responsible for a surprisingly large amount of global warming. So the question is, can we get rid of them? Contrails, short for condensation trails, are essentially artificial cirrus clouds because they're created by planes flying through the upper atmosphere, typically at least 5 miles above the ground.
When the plane flies through areas that are known as ice supersaturated regions, the soot from the exhaust can sometimes nucleate small droplets and form ice.
Most of these contrails dissipate quite quickly, but for a very small fraction of flights, some of them actually spread out. And when they spread out, especially in the late afternoon and evening, they trap heat into the Earth's atmosphere. So surprisingly, contrails are actually responsible for about 35% of the environmental impact of flying. But planes don't necessarily have to create them.
You can't fly without burning fuel, but you can fly without creating a contrail. Just to avoid the super humid regions in the sky.
These people you just heard from, who are seemingly obsessed with contrails, they're researchers on Google's climate and energy team, which looks for ways that AI and machine learning can help tackle climate change.
Carl on our team read a paper and ultimately came to Google Research and said, is there something that we can do?
Carl?
Yeah, that's me. I'm the one who's making all this noise right now. So the paper basically said, to avoid making contrails, all you really have to do is change the altitudes of a small fraction of all flights by relatively small amounts, away from regions in which the humidity is very high. And I read this, and I said, okay, it's only a small percent of all flights. This can potentially get done. But it was soon realized this is a bigger problem than we can solve ourselves. We're not aviation experts. We're going to need help.
Contrails has been widely researched for many decades. In my own case, I've been working on the topic for about 7 years. I'm really excited about the potential for machine learning to push this research forward. Integrating these new analytical tools will enable much more rapid progress in very challenging problems.
Contrail avoidance is very complicated. There's a weather database, which is huge. There's a flight database, which is huge. There's a satellites data, that's also huge. But getting big databases together is something we're good at. Contrail prediction is actually quite difficult because weather forecasts don't do the greatest job predicting humidity that high up. So we're taking sort of a different approach using image recognition and satellite data.
All these satellites take so many images, but we now have the compute ability to process the images. It makes sense in this incredible data set. Kind of like machine learning algorithms to help pick out a cat or pick out a cappuccino in your photos.
But detecting contrails is harder because they look a lot like cirrus clouds. So before we could train the algorithm, we had to teach ourselves how to find them. And then we basically put together contrails labeling parties.
It's quite difficult to identify contrails.
It takes a little bit of practice.
There's a lot of sort of borderline cases.
Natural cirrus kind of looks wispier and has tails falling off of it.
The team and other people they trained spent hundreds of hours tracing the outlines of thousands and thousands of contrails, all to create a data set of labeled imagery, so the machine learning algorithm could learn what was a contrail and what wasn't.
So right now, we've built a demo which can basically forecast where contrails are going to be.
It's just like a big map that's saying, look, planes flying at this altitude will make a contrail, so let's not fly any planes through there.
We felt confident in the technology, but to really prove that contrail avoidance is possible, you just need to do it in the real world, actually moving real planes, working with real pilots. So that's when we actually reached out to the largest airline in the world.
When Google approached us about contrail research, my first thought was, we're going to do what? But after looking at and reviewing the data, we decided, let's go ahead and fly. For our demonstration flights, we have put the tool in the pilot's hand, and then we can determine either to climb a little higher or descend a little bit lower.
Up to and maintain 12,000. the contrail avoidance. It was very easy, very intuitive. We already change altitudes pretty often to avoid turbulence, so this is completely similar. In the future, it could change how we flight plan our airplanes, and I think that is incredible.
These trials with American Airlines are really the first step, but they're going to be larger questions we run into, like, can we do this at scale? How do we work with air traffic control? And the new science has shown that the heat trapped by a nighttime contrail can be magnitudes greater than daytime contrails. So how do we target the ones that are most important?
As we continue to scale up contrail avoidance, it will take so many people's efforts across so many different sectors.
The urgency of the problem is so great, we really want to just move as fast as we can.
The great thing about contrail avoidance is this is something which you can roll out now. You know, you could change the fuel in the airplanes, you could change the way the airplane engines work, but it's going to take a really long time. No one's going to throw out the perfectly good plane.
The longer we wait, the harder the problem gets. We have a duty to future generations to get aviation to zero impact. And I think there is now emerging a path that gets us there.
I see contrails all the time now.
I see them everywhere.
It's one of those things that when you see them, you can't unsee them.
Now, I see them all the time, and my kids give me grief. Dad, there's a contrail, get rid of it.